Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Identify the starting material and its structure. C3H7I is propyl iodide. Since KOH AlC, alcoholic KOH, is a dehydrohalogenation, E2 elimination reagent, it converts an alkyl halide to an alkene. Starting from 1-iodopropane, N-propyl iodide, CH3CH to CH2I, elimination gives propene, CH3, CH is equal to CH2, compound A. Even from 2-iodopropane, elimination gives propene CH3, CH is equal to CH2. Moving on to the next step. A. Propene, CH2 is equal to CH, CH3, reacts with NBS, N-bromosuccinimide, under heat, delta. NBS at elevated temperature performs allylic bromination via a radical mechanism. The allylic position in propene is the CH3 group, C3, giving allyl bromide, CH2 is equal to CH, CH2Br, compound B. Moving on to the next step. B. Allyl bromide, CH2 is equal to CH, CH2Br, reacts with KCN in alcoholic solution. KCN is a nucleophile, CN-, that undergoes SN2 substitution on the primary allylic bromide. The CN displaces Br to give CH2 is equal to CH, CH2CN, allyl cyanide, 3-butanenitrile. This is compound C. And for the final step, A. CH3 to CHCN, this would require a secondary substrate not consistent with allyl bromide plus KCN. B. CH2 is equal to CH, CH to CN, this matches the product of SN2 of CN on allyl bromide. Correct. C. BrCH is equal to CHCN, this would require addition, not substitution, not the product here. D. CH2 is equal to CHCH, CN, Br, this has both Br and CN retained, which is not the product of simple SN2 substitution. Therefore, the correct answer is B. Therefore, the correct answer is option B.